Hi everyone, so today I'll be discussing about question number 6 of tutorial 2 KIL2010 Biochemistry. Okay. Alright, so it's given here that it's mentioned here that protozoa is the cell, yeah. Protozoa is a cell which consumes the it's mentioned here non-viable bacteria. So the non-viable bacteria is not a competitor or something that is living thing. It's already dead. So protozoa will consume this, which leads to the like we equate the substrate as the non-viable bacteria. Sorry for my handwriting. Okay, so if you guys have read through the question number 6, it mentions here that the minimum doubling time is 6.5 hours, and the yield of the I think it's biomass over the bacteria. Again, it mentions bacteria, but it's a dead bacteria. Just put that in your mind. Is 0.33. Another one is the substrate concentration. Substrate constant is 12 milligram per liter. So the protozoa are cultured at steady state in a chemostat using a feed stream containing. Feed stream is 10 gram per liter. So this is actually the substrate lah. Yeah, substrate. So 10 grams of non-viable bacteria. So this is the substrate. Now let's go to the first question. What is the maximum dilution rate? Maximum dilution rate for operation of the chemostat. Based on your notes, you can actually assume that D max is equivalent to mu max when KI is way lesser than the than the SI, the concentration of the growth limiting substrate. Okay, so having this, we can already know that from here, this is the TD 6.5 hours. Minimum doubling time actually telling you that telling you that there is a maximum growth rate. Alright, because for example, just sketch this, and this is the mu. Don't forget the asymptote here. Okay, just sketch here. Sorry, it's a bit not nice, but it's okay. This is Ks is equal to S. This is when mu max is half lah, and this is mu max. So I think this is the example of the drawing. So TD mean is 6.5 hours, which means that we need to write this formula ln 2. You guys can actually derive your own, but if you guys want to memorize the formula, yeah, you can. It's equals to mu max. So now mu max is ln 2 over 6.5 hours, yeah. ln 2 over 6.5 hours. Is it this? Yeah, 0.1066 per hour. Alright, and then as we already equate D max is equivalent to mu max, therefore max dilution rate is equals to 0.1066 per hour. You guys can see here that the Ks, which is the substrate constant, is even way lesser compared with the substrate, the initial substrate here, 10 gram per liter, yeah. Okay, so take that into consideration. Now, let's move on to question B. Sorry, it's a bit messy. Question B, C and D is just analyzing what happens if we make it half, what happens if we 3/4 of the maximum, and also D is 1/3 of the dilution rate. We'll look at one by one. So question B, what is the concentration of the protozoa when the operating dilution rate? The operating dilution rate is half of the maximum. So just calculate the new D lah for question B, which is 0.1066 per hour. Alright. Wait, yeah. What happened to my calculator? 1/2. Sorry. 2 times with 0.1066. It gives you 0.0533 per hour. So now, what's the next step that we need to find is to find the X, because X refers to the cell. So you guys can actually refer to this formula, Si minus dKs. I believe this one will be given during the finals, so don't worry about it. The ones that you need to memorize is like Monod equation. You need to also memorize the doubling time, and also the enzymes lah, like the Achilles maintain equation, etc. The simple ones in general. So I think this one is complex one, so we have to just know how to use it. Might come out during exam. Okay, and then here is given that SI is, have you calculated SI? SI is 10 gram lah, 10 gram per liter. Okay, minus with 0.0533 per hour, multiply with the 12 times gram per liter. Mu max from the original one, that is 0.1066 per hour, minus with 0.0533 per hour. You multiply with the one given, y-axis is 0.33. Okay, so you do calculation lah. So 10, 0.0533 times 12. So you'll get this one lah, 3.296. So 3.296. What's the unit? It's very important to write unit, or else the marks will be deducted. Gram per liter. Okay. And then the next one is the concentration when it's 3/4. I'll skip C because I think it's the same step, so I don't want to waste time. So you guys can do it yourself and you guys can check lah. Okay. Now let's move on to the biomass productivity. Biomass productivity. This biomass productivity is a complex equation, so it will be given. So this is the one that we need to use later. Si minus dKs over mu max minus d y-axis. So that is d here, which is the one that causes it to become a biomass productivity. So question is asking, what is the mass productivity when the dilution rate is 1/3 of the maximum? Now, D is only 1/3, which means that like this is the new D for question D only. So you get this one 0.0355 per hour. Now Qx is 0.0355. Si from the previous question is 10 gram per liter. minus with 0.0355 multiply with the substrate constant of 12 times 10 power negative 3, then 0.1066 per hour, which is the mu max, minus with 0.0355. Okay, so this is per hour. Then you multiply with the what is it called, the selectivity yield. Okay, alright, now just calculate only. This. So you will get let me just check. Okay, we get 0.117. Okay, what you need to put is gram per liter hour. So it's depending on this unit. Okay, you guys need to check properly the units. So for example, this one doesn't have unit, so no unit. This one is gram per liter, this one is per hour. So you multiply the units together, you'll get this unit, gram per liter hour. Very simple, but you guys need to, we need to actually see one by one. Alright, that's all from me. Thank you.